In this video, we're going to talk about how to balance redox reactions in acidic and basic solutions. So there is actually a PDF file that shows step by step how to do this. So print that out before you start this video and follow along using that. We're going to work these reactions out step by step. So the PDF file that I'm talking about will be posted on Canvas. Make sure you've printed that out. That has the steps for balancing redox reactions in acidic and basic solutions. And we're going to be walking through those steps together in this video. So let's take the first reaction on that handout. We have MnO4 negative plus iron 2 positive yields iron 3 positive plus Mn 2 positive. So the first thing we want to do is identify what has been oxidized and what has been reduced. And we need to write separate equations for those. So let's start by assigning our oxidation states. So if we start with MnO4 negative, we know that oxygen always has a 2 negative charge on it. So 2 negative times 4 is 8 negative. We want this compound to have a negative charge, so that means manganese has a 7 positive charge on it. Iron we know has a 2 positive because we're told that. This iron on the product side we know has a 3 positive charge because we're told that. And the last manganese over here has a 2 positive charge on it. So, if we look at manganese, manganese goes from a 7 positive to a 2 positive, which means that it gains some electrons. So manganese underwent reduction, and iron went from a 2 positive to a 3 positive, so it lost an electron, which means that it underwent oxidation. So we can write half reactions for these. If we take the manganese half reaction, we have MnO4, and let's write this in the middle here. MnO4 negative gives us Mn2 positive. Now to go from MnO4 negative to Mn2 positive, we went from a 7 positive charge on manganese to a 2 positive charge on manganese, which means that it had to gain 5 electrons. So we're going to add the 5 electrons in here. And then let's go ahead and write the half reaction for iron, and then we'll go back and start balancing these. So for iron, we have Fe2 positive gave us Fe3 positive, and to go from 2 positive to 3 positive, we lost an electron, which means that an electron is one of our products. Now, we want to balance each one of these in acidic solution. So the way that we do that, and we're going to start with the MnO4 plus 5e negative gives us Mn2 positive. The first thing that we do is we balance everything in the reaction except for hydrogen and oxygen. So in this case, the only thing in the reaction besides hydrogen and oxygen is the manganese. And there's one manganese on the reactant side and one on the product side. So we're good there. We balance oxygen using H2O. So if we look at the reactant side, we have 4 oxygens here, and we have none on the product side. So water only has 1 oxygen in it, which means if we want to make the oxygens even, we have to add 4 waters to the product side here. And then we balance hydrogen using H+. So we put 4 waters over here on the product side. This is the only place we have hydrogen. So 4 times 2 is 8, which means I need to add 8 hydrogens to the reactant side. So I'm going to add 8 H+'s here. And that takes care of everything we need to do. We already balanced the charge using electrons. We put our 5 electrons in here. So we're good on the first reaction. So the second reaction, we don't have any oxygen in there. Our iron is already balanced. There's 1 on each side. And we don't have any hydrogens we need to balance. So that part is taken care of. Now the next thing that we need to do is we need to add these reactions back together. Now to do that, the total number of electrons needs to be the same in our reduction half reaction and our oxidation half reaction, because we have to be able to cancel out the electrons. The overall cell reaction should never have electrons in it. So we're going to multiply the second reaction times 5 so that we will have the same number of electrons. So when we do that, we can copy our first reaction down. So we have 8H plus MnO4 negative plus 5E negative yields Mn2 positive plus 4 waters. Our second reaction, we're going to multiply everything times 5. So we're going to get 5 iron 2 plus yields 5 iron 3 plus 5E negative. So now we can add together our oxidation half reaction and our reduction half reaction and get the overall cell reaction. So the 5 electrons cancel out. We have 5 electrons on the reactant side and 5 on the product side. So we're done because we don't have anything else here that cancels out. And we can write this down. We have 8H plus MnO4 negative plus 5 iron 3 positive gives us manganese 2 positive plus 4 waters plus 5 iron 3 positive. So this is our overall cell reaction. So let's take a look at another example here. We have Cr2O7 2 negative plus C2H5OH yields Cr3 positive plus CO2. So let's go through and assign oxidation states here. So if we start with Cr2O7 2 negative, oxygen would have a 2 negative charge. So 2 negative times 7 would give us a total of 14 negative. But we want 2 negative to be left over. So we actually only have 12 negative that we need to balance. If we divide that by 2, each chromium would have a 6 positive charge on it. If you look at C2H5OH, we know that oxygen has a 2 negative charge on it. Hydrogen has a positive charge on it. So we have 5 hydrogens here plus 1 here is a total of 6 positive. And we have 2 negative charge, which means that we need a 4 negative to balance this. If we divide that by 2, each carbon would have a 2 negative charge on it. Chromium has a 3 positive charge because we're told that. And then if we look at carbon dioxide, each oxygen has a 2 negative charge on it. So each carbon, 2 negative times 2 is 4 negative, which means that carbon would have a 4 positive charge on it. So if we take a look at this, we don't have any hydrogens on the product side anyway right now. So hydrogen can't really change. Oxygen stays a 2 negative. But chromium goes from a 6 positive to a 3 positive. So it gained some electrons, which means that it underwent reduction. And then carbon goes from a 2 negative to a 4 positive, so it underwent oxidation. So let's separate out our half reactions. So we're going to start with our C2H5OH, since that undergoes oxidation. And that gives us CO2. And then our other reaction, we have Cr2O7 2 negative gives us Cr3 positive. So if we take a look at the oxidation reaction, the first thing we always need to do is make sure that the reaction is balanced, everything except for oxygen and hydrogen. So the only thing that we have besides oxygen and hydrogen in this first reaction here is carbon. So if we look at the carbon, we have 2 carbons on the reactant side and only 1 on the product side. So we need to put a 2 in here to balance the carbons. Now to take care of our electrons, we go from a 2 negative to a 4 positive. So we gained 6 electrons, but we've got 2 carbons here. So we actually had to transfer 12 electrons. So we lost 12 electrons, which means the electrons are products. And then what we have to do is balance our oxygens and our hydrogens. So we have 1 oxygen on the reactant side, and we have 4 oxygens on our product side. So we need to add water, and we need to add 3 water so that we'll have 3 more oxygens on the reactant side. On the product side, now our oxygens are balanced, but we have hydrogen on the reactant side and not on the product side. So we have 3 times 2 is 6, plus we have 6 more hydrogens here on the reactant side. So that's a total of 12 hydrogens that we need to add. So that balances our oxidation reaction. If we look at our reduction reaction, we balance everything except for hydrogen and oxygen. So we've got 2 chromiums on the reactant side and only 1 on the product side, which means that we need to put a 2 here. Chromium went from 6 positive to 3 positive, so we gain 3 electrons. But there are 2 chromiums, so we actually had to transfer 6 electrons. So we're taking care of our electrons now. We need to add some oxygens to our product side. We have 7 on the oxygens on the reactant side and none on the product side. So we have 7 waters that we're going to add to balance the oxygens. And now we have oxygen on our product side, but we need hydrogens on the reactant side. So 7 times 2 is 14. So that gives us plus 14H positive. So now we can balance our electrons. We have 12 in the first reaction and only 6 in the second reaction. So we need to multiply our second reaction times 2 to balance this. So when we do that, we're going to go ahead and copy the first reaction down. So we have 3 waters gives us 2 carbon dioxide plus 12E negative, so 12 electrons, plus 12H positive. Then our second reaction, we've got to multiply everything by 2, so we're going to have 28H positive plus Cr2O7 2 negative plus 6 electrons. Actually, we're going to have 12 electrons. And I also forgot to multiply my Cr2O7 times 2. So we have Cr2O7 2 negative plus 12E negative gives us 4 chromiums plus 14 waters. Oops, that's not a positive charge. So now we can add this together. So the electrons cancel. We have 12 in our first reaction and 12 in our second reaction. But this time we have water and hydrogen on both sides of both This time we also have water and hydrogen in our equations. So we need to see if those cancel each other out. So let's take a look here. We have 3 waters in our first reaction and 14 on the product side of our second reaction. So we have these 3 waters will cancel out 3 of these, which leaves us with 11 waters. And we have 12H plus on the product side of our first reaction, 28 on the reactant side of our second reaction. So these 12H pluses will cancel with 12 of these and leave us with 16H pluses. So now we can copy all of this down. So we have C2H5OH plus 16H plus 2 Cr2O7 2 negative, that's a negative there, gives us 2 carbon dioxide plus 4 Cr3 positive plus 11 H2O. So this is our overall cell reaction. So now let's talk about how to balance these reactions in basic solution. So there's one additional step if we're balancing a reaction in basic solution. we follow the same steps we did to balance the reaction in acidic solution. And then we add one additional step. We add hydroxide ions to neutralize the H pluses. So let's take our first reaction. And we're going to go ahead and write down the overall reaction that we came up with. Because all the work we did for an acidic reaction is still true. We just have one more step that we need to do. So let's copy this overall reaction here over to this slide. So we have 8H pluses plus MnO4 negative plus 5 irons yields Mn2 positive plus 4 waters plus 5 Fe3 positive. So we're going to add enough OH ions to completely neutralize the H plus. So we have 8 H pluses. That means that we need to add 8 OH negative to each side. So when we do that, H plus and OH negative, when you put those together, we know makes water. So H positive and OH negative will give us water. So if we have 8 H positives and 8 OH negatives, we're going to get 8 waters plus MnO4 negative plus 5 Mn2 positive is going to give us Mn2 positive plus 4 waters plus 5 iron 3 positive plus 8 OH negative. And then we have water on both sides, so we need to cancel some of that out. So we have 4 waters on the product side and 8 on the reactant side. So these 4 waters will cancel with 4 of these. And we're left with 4H2O plus MnO4 negative plus 5 iron 2 positive yields Mn2 positive plus 5 iron 3 positive plus 8 OH negative. So this would be our reaction in basic solution. So once we've done all that work to do an acidic solution, if you're asked to balance a redox reaction in basic solution, we're just adding one more step to that. All we have to do is add enough hydroxide to neutralize all the protons. So let's take a look at our other reaction that we had. We had C2H5OH plus 2Cr2O7 2 negative plus 16H positive gives us 2 carbon dioxide plus 4 Cr3 positive plus 11 H2O. So in this case we have 16 H positives on our reactant side. So we're going to add 16 OH negatives to neutralize that. And we're going to do it on both sides. So that gives us C2H5OH plus 2Cr2O7 2 negative plus 16 waters, because we have 16 H pluses and 16 OH negatives, that gives us 2 CO2 plus 4 Cr3 positive plus 11 water plus 16 OH negative. And then the last thing that we need to do is we need to cancel out any water that shows up on both sides. So we have 11 waters here on the product side and 16 on the reactant side. So 11 of these waters are going to cancel with 11 of these, and we're going to be left with 5 waters. So we have C2H5OH plus 2Cr2O7 2 negative plus 5H2O yields 2 carbon dioxide plus 4 Cr3 positive plus 16 OH negative. So that is our reaction when we balance it in basic solution. So we will stop here and we'll work with some more electrochemistry in the next video.